So moving on from that, the Q cycle in complex 3, our cytochrome Cs both have electrons on them now, and we can move on farther down in our membrane. And so our cytochrome Cs, they are not going to exist in the membrane. They do not have the isoprenoid tail that your coenzyme Q has, so they have to exist on the membrane surface, but not within the membrane itself. And so where are they being used? They're being used in complex 4. They're being used here. Okay, this is going to be complex 4. And this one is called cytochrome C oxidase. Okay, so this complex, the total goal is to reduce an oxygen molecule that's being held all the way to the final electron acceptor, which is going to be turned into water. So what do we have? We have cytochrome Cs that have electrons on them. We need a total of 4 cytochrome C. Okay, cytochrome C, okay, that's 4 electrons, a total of 4 electrons, because each one can only carry 1 electron. Those will get donated into this copper center, CuA, and will get passed again to a iron center, cytochrome A, Fe, which is for iron, and then will get passed down into the centers that are coordinating the oxygen molecule. So you'll have a cytochrome A3 iron center, and you'll have a copper B center. And this right here, these two, they are going to be coordinating your oxygen molecule. They're going to be holding that oxygen molecule there. And as you get progressively more electrons onto the oxygen, you eventually, after the 4 electrons, will get this reduced to 2 water molecules, okay, for stoichiometry. So we have our 2 water molecules. All right, this is from 4 electrons from cytochrome C. One thing I want to mention is, so obviously a cytochrome C can only pass 1 electron at a time. So the electrons aren't delivered all 4 at once, they're delivered 1 at a time. So something important is after 2 electrons are delivered to oxygen, we get the generation of something called hydrogen peroxide. And hydrogen peroxide is a reactive species, which if left around for a long period of time, just like the Q radical, can cause cellular damage. So that's why it's important that you have enough cytochrome C to completely deliver all 4 electrons to fully reduce it to water, so you don't have, again, a reactive species sitting around in your cell. This complex, it goes all the way through the membrane, and it can also pump 4 protons.